Okay, so now we're going to turn to computing slopes of tangent lines. In the previous video, we discussed what it meant to be a tangent line, and we kind of developed this formula for the slope of the tangent line. Slope of the tangent line is the limit as h goes to 0 of f of x plus h minus f of x all over h. And a really key idea here, this is a 0 over 0 limit. This is a 0 over 0 limit. And so all of the limit techniques from a previous chapter for evaluating those 0 over 0 limits are going to come into play here. So we begin with this problem. We want to find the slope of the tangent line to f of x equals x squared at the point 2, 4. So we want to find the slope of that curve at that point. And so we begin the problem by saying, okay, well, slope of the tangent line. Here I know x is equal to 2, so in that formula up above, I'm going to plug 2 in for x. H is the variable that's involved in the limit. So we'll address that a little bit later as we're working the problem out. Again, these limits here for these slopes of the tangent lines will always start out as a 0 over 0 limit. So our task is to eventually get that 0 over 0 factor to go away. So we go ahead and we evaluate. What is f of 2 plus h? Well, remember from our difference quotients that we're going to take 2 plus h and plug it into the x squared function. So we'll have limit h goes to 0 of 2 plus h, that quantity squared, minus f of 2, which is just 2 squared. And then we go through and we simplify the algebra. So 2 plus h squared is 2 plus h times 2 plus h. If you multiply that out, we get limit as h goes to 0 of 4 plus 4h plus h squared minus 4 all over h. And now that's good because we have something that can simplify. We have something that can simplify. So those 4 can just cancel out. And then I want you to notice that the h's that remain in the top can be taken out as a common factor. So we can take an h out of both things remaining in the top, leaving us with the limit as h goes to 0 of h times 4 minus h all over h. We can then cancel out that 0 factor, and we would have limit as h goes to 0 of 4 minus h, which no longer has a division by 0 problem, and so we can allow h to become 0, giving us the slope of the tangent line to be 4. Giving us the slope of the tangent line to be 4. And then we ask the question, what is the equation of the tangent line at 2, 4? So we found the slope of the line at 2, 4. What's the actual equation of that line then? Well, we know the slope of our line is 4. So we can go ahead and we can plug that in. Y equals 4x plus b into our slope-intercept form. And then our only task left is to figure out what's the y-intercept, what's b. That's where we take our 0.24, plug it in for x and y. 4 equals 4 times 2 plus b. And then we can solve that equation for b. So 4 times 2 will be 8. We'll need to bring that to the other side. And we get b equals negative 4. So the equation of our tangent line is y equals 4x minus 4. Y equals 4x minus 4. So part A, we found the slope of the tangent line. And now we've used that slope along with the given point to figure out the equation of that tangent line. The final thing we want to do is we want to graph the equation together with the tangent line. And the main point of this reviews a little bit of graphing. We're just going to use graphing devices to do this. I'm using my graphing calculator app Desmos to do this. And so there is my graph. And one of the things we can see here from this graph is you could actually use that tangent line to get kind of a better feel for what this graph looks like, right? To get a better feel for how the graph is shaped by using that tangent line. So if you needed to graph something by hand, we know that y equals x squared starts down here at 0, 0. We could actually use that tangent line as a little bit of a guide to show us, to get the better shape of the graph. But the main point here is just to show how that line really is a tangent line, and it is going exactly in the same direction of the graph at that point 2, 4.